Parallelograms. It's a grade 10 lesson. I think you all have done this in your schools. Uh, so let's be okay. Now, before talking about parallelograms, I think you all know what is a quadrilateral, right? A quadrilateral is a closed plane area with four sides. I think you can see the whiteboard, right? Can you see the whiteboard? Yeah, can you hear me?
Yeah, we can see the whiteboard. Yeah, it's clear.
Okay. Now, a quadrilateral is a closed plane figure with four sides, right? Now, the parallelogram is a special case of a quadrilateral. Okay, if the opposite sides of a quadrilateral are parallel to each other, we call it as a parallelogram, right? If the opposite sides of a quadrilateral are parallel to each other, we call it a parallelogram, right? We denote parallel lines using arrowheads. If these two lines are parallel to each other, we denote this by an arrowhead like this. Okay. And if there are more than two sides which are parallel, like this, if these two lines are also parallel to each other, we can denote it by two arrowheads. And if it's three, if there are three sides, three parallel lines like this, if we something like this, if there is another two lines which are parallel to each other, we can denote this by three arrows like this. All right. This is the notation of showing parallel lines. Now the basic definition, as you see in the screen shared, it is said that what is a parallelogram? Here, a quadrilateral with both pairs of opposite sides parallel is defined as a parallelogram, right? That's the basic definition of a parallelogram. Now, if we go further, now before learning about parallelograms, we must learn about some angles, right? These angles are alternate angles. Corresponding angles and aligned angles. These angles are very useful when solving problems related to parallelograms, right? I will tell you what are these angles first. If there are two parallel lines, AB and CD, and if we join the two lines, these two angles, this pair of angles can be known as alternative angles, right? You can see an Z here. These two angles are known as alternative angles. The special thing here is that the alternative angles are equal, right? So if you want, you can write down, and if you know, just look at this. Okay, that's it. If you know this, doesn't matter. Then these are alternate angles. Then corresponding angles, right? Here in corresponding angles, if we draw a line like this, these two angles are known as corresponding angles. right? It is just like an F. The inner angle here, this angle and this angle are known as corresponding angles. Like same as the alternative angles, corresponding angles are also equal to each other, right? If this is 70 degrees, this is also 70 degrees, right? Like that. Then allied angles. The allied angle is like this. Allied angles are these angles. This one consider this as x and this consider this as y. Here x and y are allied angles, right? The special thing about allied angles is that the sum of these two angles is equal to 180 degrees, right? That is the special property of this allied angles, right? These three angles are not there in your textbook, but these are necessary when solving the problems. Okay. A special thing about those angles is that if you are given two lines like this, and if you want to say that these two lines are parallel, we can say it by using those angles, right? Here consider there's a line like this, and you are given this, these two lines are equal, these two angles are equal, x, right? Then you can say by this diagram that these two lines are parallel, because why? The alternative angles are equal, right? These are the alternate angles, those are equal, therefore these lines are parallel, right? And in the say, if in another case, we say there are two lines like this, right? And there's a line like this, and it is said that there are two angles like this which are equal, y, right? Then what can you say about the two lines? This one, we call it AB and CD. The lines AB and CD are parallel to each other. We can say this because of the corresponding angles, as the corresponding angles are equal, right? Then if you consider something like this, there are two angles like this, consider this as x and y, and it is given that x plus y is equal to 180 degrees, right? Then what? Then also we can say that AB and CD are parallel, as the allied angles, the sum of the allied angles are equal to 180 degrees, right? That's it. So that's all about the angles, alternate angles, corresponding and allied angles. Now we'll move on to the lesson. Okay. Uh, Now I will share. Now let's talk about properties of a parallelogram, right? There are certain properties of a parallelogram where when a question is given to you saying that there is a parallelogram in a diagram, you must remember these properties to solve the question, right? These properties are shown in the screen now, this shared screen. Those are opposite sides are equal, right? The opposite sides of a parallelogram are equal. Then the opposite angles are equal. Diagonals bisect the angles, but diagonals bisect the area of the parallelogram, and the diagonals bisect each other. Okay, those are the main four properties of a parallelogram. Now I will explain them in the board. It's a parallelogram. when naming a parallelogram, consider this is a parallelogram ABCD, right? ABCD. When naming a parallelogram, we can start from any corner, and you must name it in a clockwise or anti-clockwise manner, right? If not, the question when you are doing the correct question, the answer will be wrong, right? If you, for example, if you start it from here, this is A, then this is B, this becomes C, and this becomes D, right? And if we start A from here, you can mark it like this: A, B, C, D. Both ways are correct, right? That's the way of naming a parallelogram, right? Now let's see the properties. Opposite sides are equal. Now, in this parallelogram, the side AB is opposite to the side DC, right? And if this is a parallelogram, this side might be equal to this side, right? We denote it like this with a single bar. Then the opposite side of AD is BC, right? Then these two sides is also equal. And the next property is that opposite angles are equal. Consider this angle ADC. ADC. The opposite angle to the angle ADC is ABC. So these two angles will be equal if ABCD is a parallelogram, right? Then BCD. Consider the angle BCD, right? The angle opposite to the angle BCD is DAB, right? Therefore, these two angles must be also equal. You can write it here. DCB is equal to DAB, right? Then the third property is that diagonals bisect the area. A diagonal is a line which joins the opposite vertices of a parallelogram, right? Here, this is one diagonal, and this is the other diagonal. There are two diagonals in a parallelogram. Like this. And if we mark this point where the two diagonals set as O, this says the diagonals bisect each other, right? That means the line DB is bisected by the point O, right? That means this side is equal to this side. That means OD is equals to OB, right? Then in the other diagonal AC, the diagonal AC is also bisected by O. Therefore, AO is equal to OC, right? So those are the properties of a parallelogram. So when you are given a parallelogram in a question, you must remember all these properties so you can apply them to the question, right? You must. It is good if you can by heart these properties, right? When you are given these four properties, you must by heart. So it will be easy for you to do a question, right? Now let's try a question from these properties, right? I think you have done these questions, but let's do it once again so you can take a practice for me. Let's do this question. I think you can all see from the screen share the exercise 16.1, the first question, right? You guys can give a try. I'll give you about 2 minutes. Give a try and I'll do it in the board next, okay? If you have any problem, ask it from the chat, so you can unmute your mic and ask. Okay. Yeah, I think you have done the question. Jasmine has given the answers. Now I'll do it in the board quickly. Here's the parallelogram. Okay. Here it is P S Q I's. Right. The length of side PQ is given as 8 centimeters. Right. Now they are asking SR. They are asking the length of side of PQ. Now, as this is a parallelogram, you know the opposite sides are equal to each other, right? Therefore, the side SR is equal to PQ, right? Therefore, this is also 8 centimeters. Therefore, the answer for the first question, first part is 8 centimeters, right? And the second question, second part, find the magnitude of each of the angles QPS, this angle, PQR, this angle, QRS, this angle, right? Right? It is given that this angle is 130 degrees, right? Now the first question is this one. Find QPS, right? Now you know the properties. We know that opposite angles are equal in a parallelogram, right? And therefore this angle is also 130 degrees, right? Now, if we consider this part, what you can see? You can see a allied angle, pair of allied angles, right? This angle SRQ and PSR are allied angles. Now, if I write it, PSR and SRQ are allied angles. Are allied. Therefore, PSR plus SRQ should be equal to 180 degrees. Now, as this is 130 degrees plus SRQ should be equal to 180 degrees, right? Therefore, SRQ will be equal to 50 degrees. Okay, then SRQ is equal to 50 degrees, right? This is 50 degrees. Then,
are you writing something on your board?
yeah, can't you see?
I think the video is stuck.
Okay.
Oh, now it's okay.
Now it's okay, right?
Yeah.
Sorry. Okay, I have done the correction in the board. Sorry, the video is paused, right? SRQ is 50 degrees, right? Then, as in the parallelogram, as the opposite sides are equal, you can get that QPS is also equal to 50 degrees. QPS is also equal to 50 degrees, right? Therefore, the answers are QPS PS is equal to 50 degrees, PQR is equal to 130 degrees, and QRS is 50 degrees, right? Right? You can see in the board. Jasmine has sent me the answers. You are correct, right? Now let's try another question quickly. Sure. Now I'll give you about 1 minute because you are doing it fast. You can do the second question now. I'll give you 1 minute. You can try the second question. Okay, now I'll do the second question. B, C, D. Right? See then the parallel to each other. This is 78 degrees. Okay. Now they are asking find the magnitude of BCD. It is this angle, right? The angle here. Now you know that these two angles are this one and this one. Angle ABC and the angle BCD are what? Allied angles, right? Therefore, the sum of these two must be equal to 180 degrees, right? Right? Therefore, 180 should be equal to 78 degrees, which is ABC plus this one, this angle. Call it BCD, right? Therefore, the angle BCD becomes 102 degrees. Right? Then the next part. If the area of the parallelogram is 24 square centimeters, what is the area of the triangle BCD? Right? I think I missed the area part when discussing the properties, but I discuss it here. Now, here when we consider triangle BCD, right? So if we join the points B and D, we can get the triangle BCD. And you can see BD is a diagonal of the parallelogram ABCD, right? Now in the properties, we said that the diagonals bisect the area, right? That means if the whole area is A, let's consider the whole area of the parallelogram as A, right? Capital A. Then the when the one part of the ABD and DBC, the area of one part of both of those is equal to A by 2, right? Means half of the area of the full parallelogram, right? Now in this question, it says that the area of the parallelogram is 24 square centimeters, right? 24 square centimeters. CM. Right? This is parallelogram AB. Right? Then, as you know, the diagonal bisects the area of the parallelogram. We can easily say that the area of the triangle BCD is equal to half of this 24, which is 12 cm2. Right? Then they are asking what is the area of ACD. Right? If we construct this diagonal, AC diagonal, right, we can get the triangle ACD. Right? It as as it is created by the diagonal, this part will also have the have half of the area of the parallelogram, right? Because it's a part of the bisected part of the parallelogram. Therefore, the area of ACD triangle is also equal to 12 cm2, right? Right. And let's do one other question from this one. Right. Let's do the question number 7. The some has sent me the answers. Jasmine and Devasi Hermione. Your answers are correct. Yeah, good. Now try the 7th question. Okay, now let's do the question 7. Okay. Now the question says there's a diagram given like this. Right? Given these. Now the first question is find the length of BC, right? BC, right? And here it's given that the figure depicts two parallelograms ABCD and ADEF, right? Now here for the first part, you can consider the parallelogram ABCD, right? You know the opposite sides of parallelogram are equal to each other, right? Now here AB is given, AD is given as 5 centimeters. Therefore, it's very easy. You can see BC is the opposite side of AD. Therefore, it is also equal to 5 centimeters, right? Then second part, uh, find the magnitudes of each of the angles, right? They are asking for CFD, this angle, ADC, this angle, and ECD, this angle, right? Like this. First, the angle CDF, right? Now, as you can see, in the triangle CFD, right? This is a special triangle, right? All the three sides are equal to each other. That means this triangle is a equilateral triangle, right? Then uh, what is the size of an angle here? It's 60 degrees, right? One angle is equal to 60 degrees. This angle is also 60. This angle is also 60 degrees, and this angle is also 60 degrees, right? Because CDF is an equilateral triangle, right? Therefore, you can write as CDF triangle is equilateral. You can say the angle CDCF is equal to 60 degrees, right? Yes, CFD, both are correct. They are asking for CFD, right? CFD. It's also equal to 60 degrees, right? CFD is of the equilateral triangle, right? 60 degrees. Then they are asking for ADC, this angle. Now you know this angle is also 60, this angle is also 60, right? What can you say about these two angles? This one, let's mark it as X, and this angle X. You can see that as these two lines are parallel, as given in the diagram in the screen, you can see I didn't mark all those in the whiteboard. Uh, these two are parallel, right? Therefore, the angles marked as X becomes alternate angles, right? Right? Now we know this angle, right? You know that alternative angles are equal to each other. As we know this angle is also equal to this angle, right? Therefore, as DCF and ADC are alternate angles, they are equal, right? Therefore, as CDCF is equal to 60 degrees, and the angle ADC is also equal to 60 degrees, right? Then the angle ECD, right? ECD. You can do this in many methods. You can use the aligned angles here, or you can just use the angles on a straight line, right? You know this angle, and then this angle in a straight line is equal to 180 degrees, right? And here this full angle becomes 180 degrees. As you know, X as 60 degrees, this angle becomes 180 minus 60 degrees, which is 120 degrees, right? Okay, therefore ECD is equal to 120 degrees. Okay, those are the answers. Sorry. Now you can see it now, right? Okay. Your answers are correct. The ones you are ready. ECD, I think. 126 degrees. Okay. Now you can see the board, right? Okay. Now. Now let's move on. Now we are going to prove those properties, right? In the parallelogram, we discuss some properties. Now we are going to prove those properties, right? Using congruency of triangles, right? I'm going to prove it in the whiteboard now. You can see here. For you, the first theorem is only there for proving, right? Second part is not there for you. Okay. The things we are going to prove is that opposite sides are equal in a parallelogram. Opposite sides are equal. Opposite angles are equal, and the area of a parallelogram is bisected by each diagonal. Those are the three things that we are going to prove. It is there in your textbook also. I will put it, and I will do it in the whiteboard as well. Okay. And this is the other property in a parallelogram. The diagonals bisect each other. Okay. Okay. This is the proof. I'm gonna explain it. This is the parallelogram we are going to use. Okay. It has A, B, C, D. The opposite sides are parallel to each other. Right? That is the only thing. Right? Now we are going to prove first opposite sides are equal. That means we must show that first one, we must show that AB, this side, is equal to this side, right? AB is equal to BC, and the other one, other side, DAAD is equal to BC, right? AD equals to BC. Then the second one, second property is what? Opposite angles are equal to each other, right? That means these angles. And these two. That means BAD. You can see this in the textbook as well. I'm just writing. BAD is equal to BCD. BAD is equal to BCD, right? These two angles are equal, and the other two, ADC and BCD. ADC and ABC, sorry, ABC. ADC and ABC. These two angles are also equal. Those are the things that we are going to prove. And the third property is that the area of the parallelogram is bisected by each diagonal, right? Prove that we are doing a construction, right? In the proof, you must write it like as shown in the shared screen in the textbook. Now I'm not going to write it. Just I'm going to do the construction. In doing construction, we are using dotted lines. Now I'm going to construct the diagonal BD to show the third property, right? Third property. So that we are going to prove that the area of the triangle ABD is equal to area of the triangle BCD, right? BCD, right? That is the thing we are going to prove. Okay. Now let's start the proof. For here we are going to show that the triangles ABD and the triangle BCD are congruent to each other. This triangle and this triangle are congruent to each other, right? by saying so, we can easily show the three properties that we are going to show, right? Now let's start. Here also we are using alternate angles. Right? Here we are saying these. I'm going to give a summary first. You can see here. Now you know this angle is equal to this angle, right? Because what? Alternate angles, right? Then you also know, right? This angle is also equal to what? When you consider this part, this is also alternate, right? Right. Yeah, it's not clear. Right. First we said these two are equal due to alternate angles, right? Then these two angles, this one and this one, right? Because of this alternate angle, this is it, right? These two angles are also equal, right? And this side, it is common to both triangles ABD and ABCD, right? This side is common. Therefore, by the case angle side, this is the angle, this is the other angle, and this is the side, right? Angle side, we can say these two triangles are congruent, right? The way you can write is shown in the textbook, is shown in the screen share. So you can write like that, right? Then when we prove that the triangles ABD, triangle ABD is congruent to triangle BCD, right? How we can say these three properties are correct? Let's see. Right? Opposite sides are equal, right? As you may know, the corresponding sides of two sides, angles, if you can call those elements, the corresponding elements of congruent triangles are equal. This is the property that we are using here, right? If we consider the corresponding sides and angles in these two triangles, we can say the first part and second part very easy, right? In the first part, you must say the two sides are equal, right? And here we consider these are the two triangles. This angle, right? This side, right? This is this side. The corresponding side to this one is this one, right? As the two triangles are congruent, these two sides are equal, right? The corresponding side to this one is this one. Therefore, these two sides are equal as the triangles are congruent. Similarly, if you consider angles, you can see the corresponding angles of this one into this triangle is this one, right? As those two are equal, therefore those two become equal because of the congruency. Similarly, like that, yeah, you can see opposite, not that side, you can see from this side, right? Opposite angles are equal. Corresponding angle to this side is this side, right? Therefore, we can say these two are equal. To prove the other this one, you must construct the other diagonal and do the same thing. Right? That's the proof of the three properties, right? Whole time this will be asked, but in the O-level paper, it's not asked directly, but it's good to know, right? Now let's do some more exercises. If you have any question, you can put it in the chat. Okay, now 16.2. You can try a question. Try the question number 5. I'll give you 3 minutes for that. If you want any question to be done in these exercises, put it in the chat. I will do it for you. If you have a hard one, if you have tried this before, if you have a hard one, you can put it in the chat so I can do it for you. Anyway, right? How we can show the proofing steps. Okay. The proofing steps, it's you can see it in the I'm scrolling the screen share now for a while. Here the steps are here given clearly, right? That's why I didn't write it on the board. Here in the screen share, you can see these steps are very clear, right? You can see to be proved, it is said AB equal DC. This is very clear. If you can write like this, this is the best way to prove it, right? Right, Jasmine question. This is question. She's asking how can show the proving steps, right? These are the proving steps, right? In the page 165 of your textbook, grade 10. I'm talking about the question. All right. You are correct. Talking about the question number 5, then, right? I asked you to do the question number 5. Okay. Ask you to do the question number 5, and I will do it in the board, right? If you got the answer, okay. All right. I will also do it on the board. Try the question number 5 now. Proof question. No, you can mark it yourself. I will do it on the board. You can see whether it's correct by yourself. Okay. Proving questions. Okay, now I'll do the friction. Now here, parallelogram. Right now, figure illustrates a parallelogram ABC. Right, when the question says that it's a parallelogram, the properties of it should come to your mind, right? That means the side AD is parallel to CB, BC is parallel to AB, and those opposite sides are equal, and the bisects, diagonals bisect each other. All those properties should come to your mind as soon as you see the word parallelogram in the fiction, right? The properties of the parallelogram, right? So it becomes very easy to solve the question, right? Then in the question they are saying the points x and y lie on the side view respectively such that dx is equal to dy, right? Now we are asked to show that, prove that triangle ABY is congruent to triangle DCX, right? Let's try this. Right? Now I'll show you how we are going to do that. Now we already know that the side DX is equal to BY, right? Those are two sides of the triangles that we are going to prove that those are congruent, right? And if we consider these two sides, right? These two sides are the two sides of the parallelogram, right? Opposite sides of the parallelogram ABCD. That means these two are also equal to each other because that's the property of a parallelogram, right? Then what about this angle? These two angles. Those are opposite angles of a parallelogram, right? Therefore, those two angles are also equal to each other, right? Therefore, we can say these two angles are congruent by the case SAS, right? Now I show you how to write it. I prove in the triangles ABYN, ABYN, DCX, DCX, right? First one, dy is equal to dx, right? You can put it in brackets as given, as it is given in the equation, right? Then the second one, you can say this side dba is equal to dc. This is because that's the reason opposite sides of a parallelogram are equal, right? Then the last one, the angle. The angle ABY is equal to the angle CDX, right? The reason is the opposite, not gonna write the full thing here, opposite angles of parallelogram are equal, right? Therefore, by the case side angle side is the two triangles are the triangles when the two triangles ABY and DCX are congruent. Okay. Like that, you can prove it. Yeah. Note it down if you haven't done it. So you can check your answers both. Now I'll do the second part if you have write it down. Now they are asking to show us that AY is parallel to XC. That means these two lines, right? AY and XC. Now here, what can we use? Just see, we can use those angles that I told you earlier, alternate, allied, or corresponding. Right? If you see here, I have put it in here so you can see. I do it here. Right? There is something like this. These two lines are parallel, and there is something like this. If this angle I will do it after wiping this space for that. Maybe 1 minute to mark. Okay, I'll do the next part. I will erase this. Now you must see this line is parallel to this one, right? So you can see an F here, right? From an F you can say from the corresponding angles, when the corresponding angles are equal, you can see that the two lines are parallel, right? Like this. If these two angles are equal, you can see this angle, this line is parallel to this one. Okay. So we are now going to say that this angle is equal to this angle, right? Now we have proved that this triangle is congruent to this triangle, right? Therefore, by corresponding angles of congruent triangles, the angle BYA is equal to angle DXC, right? This angle. These two angles are equal by what? The congruency of the two triangles, right? Then, as these two lines are parallel, because ABCD is a parallelogram, these two becomes alternate angles, right? Therefore, these two lines also become equal to each other. That means these two lines, these two angles are equal, making these two corresponding angles which are equal. So, by that we can say the line AY and XC are parallel to each other. Right? There are other methods also we can say. This is a bit easy. Now I show you how to write it. Then, you can say that the angle AY angle B is equal to the angle CXD by as corresponding angles of congruent triangles. Right? Then we can write D X.
Sir,
Yes.
there's a problem in your writing, sir. C angle CXD. It's
Yeah.
not to be angle YCX, no, sir.
YCX. C.
First one.
You are saying this one, right?
Yes, sir.
We are considering the corresponding angles of a congruent triangle here, right? Not corresponding ones. Corresponding angles of congruent triangles, not corresponding angles of two parallel, not like the F1. I mean, not. You are telling that we must consider these two lines, right? These two angles. These are corresponding angles of a parallel, two parallel lines, right? Now we are talking about corresponding angles of congruent triangles. That means in the proof earlier we did, can't you remember? That means like corresponding elements of congruent triangles of triangle. I will show you in the screen share. Here. Since the corresponding elements of congruent triangles are equal, right? Can you see? Hello?
Yeah, sir. Fine.
Did you understand that, or should I explain it more? Here we are not considering the corresponding angle of the parallel line, right? Parallel ones. We are considering the corresponding elements of the congruent triangles, right? In the first one. Therefore, this angle AYB becomes equal to this angle, right? CXD, right? I will explain it so you can easily understand. If we take this triangle, this is ABY, right? So the angle for this, consider this angle, right? Then if we take this triangle and put it upside down, this angle becomes, this triangle be like this, right? C is like this. Then X is like this, and D is like this, right? As the two, this is that CXD angle, right? As these two triangles are congruent, that means all the sides are equal, everything is equal between these two triangles, right? Therefore, the corresponding angle of this angle to this and corresponding angle of this triangle is this angle, right? Right? Therefore, these two angles become equal. That is what I'm saying here, right? Not that something or the corresponding angle of the parallel line. Okay, I hope you can understand it now.
Yes.
Okay, now the next one. First, I say those two are equal. Then here. Now then we can say this by, then we can say the angle CXD is equal to angle XCY. XCY as alternate angles. As they are alternate angles, right? Right? These two angles are equal because those are alternate angles between two parallel lines AD and BC, right? Now we can say from axioms, no need to know that, then we can say that A by B is equal to XCY, right? That means A by B, this angle is equal to this angle, right? Now from that, what can we say, right? These two angles become corresponding angles, right? That is the thing. That's that. Because of that, we can say these two angles are parallel to each other. That's the point we are going to show. Okay. Now, as these two angles, as A by B and XCB, XCY become corresponding angles, the lines XC becomes parallel to A1, right? That's the answer. So you can write it down. Okay. Now, if you want, we can do another question or we can move on, right? I think I will move on now and I'll do some more questions at the end. Some past papers as well. Right? Now let's go to the next lesson. Just like this about the lesson that we did. I think you have note down the answer. Now let's begin the second lesson of parallelograms. Right? Here in the first lesson we learned what means the properties of a parallelogram, right? That means when a parallelogram is given to you, you know the properties of those, right? That is what we learned in the first lesson. That means we know the properties of parallelogram. If a parallelogram is given to you, you have some knowledge about it, right? In second lesson, we are going to identify parallelograms. That means when a diagram is given to you, you must be able to identify whether a parallelogram is there in the diagram, right? That is the aim of this lesson, right? You must be able, after doing this lesson, you must be able to identify whether a parallelogram is in the diagram, right? The theories are just like they are same as the first lesson. Let's go through it quickly. I'll explain each one in the board. It will be easy for you. I'll erase this now. I'll quickly say the properties, theorems. And for that, if a quadrilateral is given to you, if the opposite sides of the quadrilateral are equal, then it is a parallelogram. That's the first theorem, right? The second theorem is if the opposite angles are equal in a quadrilateral, then it's a parallelogram. The third one is if the diagonals bisect each other in a quadrilateral, then it is a parallelogram, right? And the last one is if a pair of opposite sides are equal and parallel in quadrilateral, then it's a parallelogram. You can see these are the opposites of what we learned in the first lesson, right? Right. Here we get if there's a quadrilateral with those properties, we can say it is a parallelogram, right? Okay, now I'll explain one by one. Okay, theorem 1, first one. First one is if the opposite sides of quadrilateral are equal, then it is a parallelogram, right? Suppose there's a quadrilateral like this, right? You guys can see me, right? Okay. If ABC, right? If the opposite sides are equal, right? If this is equal, right? We can say that this quadrilateral is a parallelogram. No need of any other property. If the opposite sides are parallel of a quadrilateral, we can say this figure is a parallelogram. No need. That means the other properties will be fulfilled, but it is no need to show that if the opposite sides are equal, that automatically becomes a parallelogram, right? Okay, this property is only enough to show that this is a parallelogram, right? So the other properties are also there in this figure that we learned in the first lesson, right? That means here there is a quadrilateral, right? The opposite sides are equal to each other. We can say this quadrilateral is a parallelogram, right? Then we can also say that then this becomes a parallelogram. That from this we can say that ABCD is a parallelogram, right? Parallelogram. We can get to a conclusion only from this, right? Then apply the other properties also to this, right? We can say that these two lines are parallel. These two lines are parallel. The diagonals bisect each other. We can say all those. After saying ABCD is a parallelogram just by the first theorem, right? That is, we can say that the quadrilateral is a parallelogram when the opposite sides are equal. Okay. The second one then, if the opposite angles are equal in a quadrilateral, then it's a parallelogram, right? Consider this one. Okay. Now you can see ABCD. Here these two angles are equal and these two angles are equal, which means opposite angles are equal. as the theorem says, when a quadrilateral is like this, we can say that this quadrilateral is a parallelogram. That means we can directly jump to the conclusion that this quadrilateral is a parallelogram, right? ABCD is a parallelogram. Then as we know this is a parallelogram, we can use the other properties of it as well, right? The things we learned in the first lesson, right? Suppose that there's a diagram and it says the opposite sides are equal, right? Then you can directly say that it's a parallelogram, and you can say that the opposite sides are equal, and diagonals bisect each other. All those properties you can say, right? You only need one of the theorems that I'm saying now to prove that a quadrilateral is a parallelogram, right? This is the second one. The third one. Third one is if the diagonals bisect each other in a quadrilateral, then it is a parallelogram, right? Means if parallelogram diagonals bisect each other, A, B, C, D. Consider this point as O, where the diagonals intersect each other, and if this is equal to this, and this is equal to this, right? We can say that ABCD is a parallelogram, right? That's the third theorem. And the fourth theorem is rather special. It's like this, right? No need of all the sides, right? If we in the first theorems we we just discussed, he said that opposite sides should be parallel, opposite sides should be equal, opposite angles should be equal, both opposite, right? In the for theorems 1 and 2. In here, only a pair, right? Only one pair is enough, right? But they must be equal and parallel, both. That's the difference here. So I will tell it again. When two sides of a is the pair opposite, right? If the pair of opposite sides are equal and parallel in a quadrilateral, then it is a parallelogram, right? That's the theorem. That means if we see a quadrilateral like this, we can say it's a parallelogram, and then we can give other conclusions to it, right? Now from this we know that ABCD is a parallelogram, right? Okay, I am saying again because this is very important, right? Then after that we can see these two sides also become equal, right? Because why? We have concluded that ABCD is a parallelogram as the opposite pair is equal and parallel, right? You can use the other properties after that. Here, this become equal, right? Those are the four properties. These theorems, it is good if you can by heart them. So when you look at a diagram in a question paper, you can easily identify parallelograms in it. So you can use the other properties of the parallelograms and solve the questions, right? Now let's do a simple exercise from that to make sure you got it. Let's do the 17.1. Right? Here it is to identify each other parallelograms, right? Now it's going to be the first A, B, C. Here first A, right? In here, two sides are equal and two sides are parallel, right? But will this become parallelogram? No, because this doesn't satisfy any theorem, right? If we consider the second one, B, opposite sides are equal to each other, right? This side is equal to this side, and this side is equal to this side. Opposite sides are equal, right? Zoom it again. And consider this one, right? Here you can see it rather looks like a parallelogram, but see whether it according to the second theorem, it says opposite angles should be equal, right? Here, see whether opposite angles are equal, right? Here the adjacent angles are equal, but not the opposite, right? This is 91 degrees. If the opposite angle, this angle should be 91, right? Not this one. Therefore, this is not a parallelogram, right? This one, this is a square. As you see, all the four sides are equal. Therefore, it's a parallelogram. There are special cases of parallelogram. We can you can learn it